All right, fellow calculus enthusiasts, this is assignment number 27, integration by substitution. And let's call this one example 1A. And so here's the deal on this one. We've been integrating things, but we've only been able to integrate things that were terms and powers. So here's the deal. We have a power on a group here, and you might think, well, chain rule or something, but there's no such thing for integration. If you were going to attack this in the way that we've been doing them, here's the problem. You would need to write that group down 6 times and do a whole bunch of algebra for quite a while here. All right, and 1, 2, 3, 4, 5, 6. And just to make the point, this would be a total mess. That would be x squared plus 2x plus 1. When you distribute these first two, you carry down the remaining 4, and you keep doing it, algebra. And eventually you would have a series of terms with powers, and you could integrate it using the power rule on each of those terms. What a mess. No, we don't want to do that. I mean, you could, go for it. What if I put 68th power? Have fun, all right? And again, we all know you can't just drop that in there because of the addition. So this becomes an algebraic challenge, okay? So substitution would be the way to do this. And just like anything that's brand new, I think it's my job to talk it through, and then hopefully it'll make sense. But here's the idea. If you go to Roman numeral number 1, now this is back to being an indefinite integral, so therefore we don't have limits of integration. And so substitute. Now, if you have a quantity being raised to a power, it is generally advisable that you will substitute a single variable, such as u, for that quantity being raised to a power. So the point is, we're going to replace the x plus 1 with the single variable u. All right? So you'll get used to this. The more we do, the more this will be instinctive. But if you see a quantity being raised to a power, then that's probably what you want to substitute. And so we're going to replace that original question, and in this example, that would become u to the 6th. So you'll notice I circled this in green, and the u took its place. All right. Now, every single time, it says here, make sure to substitute for every expression in the original integral. We've already replaced this with u. Every time, we're going to need to replace the dx as well. That's also going to be part of the original integral. So the point is, that would motivate us to differentiate this original. So everything gets built off of this, okay? So we will differentiate this with respect to x, du dx equals, well, that'd be dx dx, which is 1, plus 0. Differentiate with respect to x. We want to do that because we want to get a dx into the discussion. You'll see the pattern. So take your original substitution and differentiate both sides with respect to x. Now, in this case, if we, so to speak, clear the fraction, what we'll notice is that du turns out to equal basically dx. And so the nice thing, and this is an easy one, they're going to get more challenging as we go on. I started with a simple one, and we'll build from here. But you'll notice that the dx that's in the original is exactly equal to du. And so in this new integral over here, that dx can then be replaced with du. So everything in that original integral got replaced. Quantity to the 6th became u to the 6th, and dx became du. And the hope would be that this new integral over here would be an easy one to do. It will be much easier to integrate than the original. All right, so this is just a single term. We do the power rule, u to the 7th over 7. And let's remember, on an indefinite integral, we have that constant being added on. So make sure you remember the plus c. I hope you read the waitress joke. All right, waitress. And anyway, now here's the thing though. The original question was to integrate a function involving x. We were simply using the variable u to make the integration easier, but once we're done doing that integration, we need to remember to go back to the original x. So it's like x was too complicated, our x was too complicated, so we ran off with u, and then the u was easier to integrate, and then we go back to x. And keep in mind that u was x plus 1. So putting x plus 1 back in here, the answer to the original question would be x plus 1 to the 7th over 7. Substitute it back, put that quantity back in for u. And this is the integral of that original x expression. So, just like anything, you got to work a bunch of them until you get good at it. That's 1a. Let's just do a bunch of them, okay? So that's my read on that. Let's move on.